So I'm going to look now at another sort of structure where you can have two inputs and an output, but the inverter is going to appear on the Q side of the item. I'm going to stick to this piece of paper here as well. I've written on that one beneath, so I'm going to stay on this one. But I'm going to use all of these diagrams to show basically what happens. I'm just going to look at the initial AB and an OR gate first. So if I've got the AND gate, and I put a NOT gate after it, so now I've got my two levels as I did here, one NOT and the AND. If I've got that gate, then I can do the truth table for that one. And really we've done it. If we think about this quickly, we can look at all of these and quickly work them out. So to be honest, just getting these truth tables out is the important part. Let me go through this the long-winded way. So I would have a truth table A and B, which would be 0, 1, 0, 1, and B 0, 0, 1, 1. And at this point, let me call this point C. Okay, so I'll have got through my and C is going to be exactly the same as Q here, because they're both going through the AND gate, and at this point I'm going to get the old Q. So that would be 0, 0, 0, 1. Now I'm going to NOT the output, okay, because it's now going through this gate to get my new version of Q. So this is a bit trite, trivial. If I NOT it, that's going to be 1, 1, 1, 0. Okay, and Q is just going to be the same thing as that. So if I NOT C, that is going to be my output. So that is the truth table for that. Now, I'm going to do the same with the OR gate. A and B and Q. I'm going to have sort of an intermediary here, C, that comes out from this one. Let's do the table for that. A, B, 0, 1, 0, 1, 0, 0, 1, 1, and then the output for C would be my old OR table. So if you want to see it, it would be this one here. So this table. But we'll just work through it. So ORs is anything that has a 1 in it is a 1. So that's that OR gate. Okay, just the same as that. And then I'm going to NOT it. Okay, because that's C is at this position here. Then it's going to go through the NOT gate, which is going to invert it. That is going to be a 1. That is going to be a 0, a 0, a 0. So that is those two diagrams and been inverted. But what I want you to look at is that these already exist. Okay, so this gate here, the output is exactly the same as that output there. And this gate here, that output is exactly the same as that output there. And we've got 3 1s and a 0. And if you looked at lesson 6, which I told you not to, you'll have a full explanation of what that is. Now, if we were to sort of move forward, we could start looking at, and I'm not going to go too in detail, you can work them out yourselves. If we had, let's take this one here, A and B, but we're going to put the NOT gate on there, 2 inputs. Now the only reason why I'm doing this is because it's 2 input, and theoretically they could give you something like this in the exam, where we NOT that output. So actually we've got 3 gates. I can't see this happening. I can't see them doing this. I can see them doing this because we've got 2 gates and 2 inputs. The important part there is the 2. This one's got 2 inputs but 3 gates. And if we remember from earlier on, I showed you that we could have had an output that required 3 inputs. I'm going to leave that down to you to play around. So if we've got 3 inputs or 3 gates, I'm going to leave it to you to work out the tables. I'm not going to go through them, but I don't expect any of these really to appear in your exam, but I would expect these because we're just dealing with 2s. 2 gates, 2 inputs. Anyhow, I'm still going to work on this one. I'm going to cheat because to this point we already know what the output is. So if we take a look at this one here, not an A and B, then my output is this Q here. So that Q was 0, 0, 1, 0, and we can have the new Q, Q dashed, being 1, 1, 0, 1. In other words, we've inverted it. And that will have a similar truth table to one of the 4 ones that we did with either the AND or the OR. And it's probably, because it's an AND here, I'm going to find this result in the OR tables. So let's take a look. 1101, 1101. So that is the same as this one. So I could write that down. That is the same as doing, which one are we, A or not B? So really we're not producing any new truth tables because we've got 2 inputs. This one would do because it's got 3 inputs. For 2 inputs we're not producing any new truth tables by negating the output. We are just producing one that we've already done, and really if you go through all of these you'll find that we've produced all the possible combinations of outputs. So don't worry too much about these. Do what I did. Just use the result and invert it. But don't forget, this has got 3, so I wouldn't expect to see it. This has got 3, so I wouldn't expect to see it. And that really sort of sums up our logic at the moment. We can go on forever and ever and ever. It's up to you what you do. But I would certainly stop at around about this point here. Okay, with 2 inputs and maximum 2 gates. So I can't have a 3rd gate like an OR gate and an AND gate because that will produce 3 inputs. So up to you what you do. That's logic for you.